can see there on this shitty 47 microfarad, wrong valued, terrible brand IC cap, they also just clipped the old cap out and roughly soldered to it. This is a place in the amp where connections are pretty important, so I'd like that to be a lot more secure, especially if you're gigging with it, not just sitting around in the closet with it. So I'm recommending just recap the power supply here, and it'd be good for another 25 years. It's just kind of has to be done due to the quality and craftsmanship of what's going on here. We can lift a leg and measure them, but just as soon as you see those IC ones, the IC brand caps, it's just pretty much a change on site. We'll measure the dropping resistors too, they're original, and they take a lot of heat and stuff, so they've probably drifted in value pretty far, but we'll check them out, because if we can keep them, we'll keep them. But there's no originality to these caps, and there's only bad news waiting for them, so I would say let's recap the power supply. Okay, back up. There we go. Sorry about the not great lighting. Get it a little tighter here too. Yeah, that's probably all right. Okay. So, quickly checking the other tubes here. That's an old GE 12AT7 as it should be. And the rest should all be 12AX7s, and I think they are. Newer, well not newer, but later than the GE groove tubes. And electro-harmonics, newish. Reverb recovery, this is a pretty important spot. And we've got maybe another old GE. Hard to make it out, all the stencils off of it, but looks okay. Hard to tell by its looks though. Could have been a source of some of the hiss that we were hearing, like off the top. It wasn't terrible hiss, but and then sort of cheap Chinese 12AX7 in the tremolo spot. But you know, it's just the tremolo spot. There's no actual signal going through there. I should zoom in again on this choke and the heat stuff around the top of the chassis there. So yeah, just definitely taking some heat. Look at that. So, just tells you a little bit about its life. That's the solder blob that used to connect through that little hole to the death cap, which makes me think the death cap's already been removed, which is good. Alright, so we're going to flip this over. Actually, we'll tighten the bias pot first, and then we'll flip it over and see what awaits on the inside. You did send me a couple pics, so I know I'm not going to be too shocked at what I see, but we'll take a closer look. Just need my 1/2-inch wrench to tighten this bias pot. Well, this is fun. There it is. got a few turns out of it, so that's a good thing to have tight. Somebody's written in Sharpie on your chassis here, which, you know, whatever cosmetically, but also tells you a little bit about the level of tech that we were dealing with, that they had to write down that each of these were the positive end of the caps. You know, doesn't bode well for the quality of work, which you can see from the way they went about it is not great. These three look to be done a little better, but we're just going to do them all, because once you're in there, you're in there. I'm going to take this whole board up, pull all the wires, check the resistors, kill these caps, put them in from the other side. There's some wires on the other side of this board that connect from points to points, so we'll recreate those, probably be able to reuse the bus wire that's in there, clean it up nice, and you'll be good for decades. Okay, let's flip it over and see what's happening. We got our trusty hammer blocks. Actually, at this point, I should triple check, which I did off camera once already, but triple check that these caps are all drained. Give them a quick measure so I don't get zapped. Oh, half a volt. Half a volt. 0.5, yeah. All right, we're safe. Okay, flipping it over. Okay, so just give you the little tour here. Let me check that this angle is still good and the zoom is good. Might get a, oh yeah, that's pretty good. That is pretty good. Okay. So let's just go through it. Starting at the input side, original, look to be the original jacks, which is cool, and original resistors on said jacks, although we seem to be, oh no, there it is, yeah, we're good. The actual shorting jacks are shorting, so that's good. It's dirty, so we'll clean those up and tighten them. And there's a lot of like filth in and around the bottom of the chassis here, where somebody's probably mistakenly just sprayed shit, or maybe some kind of spill happened there. There's a lot of just stray solder blobs and junk laying around in the chassis here that we will clean and vacuum out. I'll give you a close-up of that maybe after I walk you through the rest of the circuit here. So, wow, yeah, so you got original coupling caps here, which is exactly what you want to see. These blue Ajax are the bee's knees. Exactly what you want in here, in all their locations. Every resistor in the signal path, except for the 3.3 meg and the 470 from the Reverb mixer, and the actual mix resistors here feeding the phase inverter, have been replaced. So all of these have been replaced with metal film. which is not, you know, not carbon comp. Like, really, they should all be these carbon comp resistors. They are a little quieter, less hiss, but they don't sound exactly like carbon comps that would have been in this amp originally. So this amp was probably kind of noisy, and somebody said, all right, I'm swapping out every resistor. So they did. And they kind of did not a great job. A lot of excess lead length and stuff going on here, but you know, it works. So continuing with the tour, oh wow, we have a really nice solder blob there. Continuing with the tour, this treble cap is original, and all of your cathode bypass caps are original. So there's a lot of talk about these cathode bypass caps. We'll measure them, but I would say that they probably, at this point in their lives, will be leaky, need to be replaced. Probably capacitance is off as well, like a little, it's drifted a bit. Anyway, there's a lot of legend about the original value of this cathode bypass cap on the trem circuit. And everyone says, yeah, you know, the schematic says 25, but they actually originally had 5 microfarad caps in here. But this is an original, and this date, code, and I don't actually see a chassis stamp in here. Oh yeah, I do. So yeah, it's definitely 1965, and this is original, so it's a 25, so that sort of clears up the myth about this being actually a 5 microfarad cap, even though the schematic says 25, because this is 25 from the factory. Original treble cap, original coupling caps for the vibrato channel, original sort of treble bleed cap on the 3.3 meg, original coupling cap here out of V4, the reverb recovery. These are all very important ones, you know, the bypass caps being original contribute a lot to the sound. If you're replacing those with fancy new film ones, it's gonna change things, so that's cool. I would say, and the phase inverter cap is also original and correct, although slightly falling apart. Just take a peek between here. It looks like the negative feedback resistor is the original and probably correct value in that case. The bias circuit, I don't know if you can see from that angle, but the bias cap has been replaced with a 47 microfarad, which is fine. It's more filtering than original, but that's probably a good thing. No one's going to complain about that. Your screen resistors have also been replaced. This is a spot where, you know, metal oxide resistors is maybe not a terrible idea. Your grid stops, though, these resistors at the bottom of the tube, sort of impeding the grid flow, have been changed. I'll measure those. My resistor color codes are not up to spec, but it's supposed to be 1.5K in that position, but the colors don't look correct to me, so I will measure yeah, 1.5K. So they've been replaced, probably unnecessarily, and with modern materials. these would have been carbon comp as well. So, you know, the good news about the not using carbon comps everywhere is that the hiss will be a little less, but the sound will be slightly different. So if I was wanting to put this to like sounding exactly like a Deluxe did in 65, I would put new old stock Allen Bradley resistors in all of those spots that are in the signal path. I would leave these screen grids, and I'd probably leave the grid stoppers as well. Although I do have some old stock Allen Bradley 1.5K carbon comps there too. So you have a little stash of carbon comps of the values that are most common in these amps. So you can see this guy here is just like all the other original resistors that have been left in the amp. So we could put a bunch of 100Ks here for the plate resistors, slope resistor, and trickier to find the 82K for this side of the phase inverter. I have some 220s for the grid leaks. So, you know, we could put it all back to stock resistor speaking, which might be cool, or it might just be not necessary. If this is like just, hey, I want this thing to be safe and sturdy while I gig, then that's more of a like, let's do the filter caps, let's check, and probably have to do the cathode bypass caps. And you know, you could leave the resistors because they're working and not noisy, so that's fine. You just sort of will have that never knowing how it would be if you had the original style of resistor in there. Depth cap has been removed. It would have been right here. Let's see how they did the power wiring. So I got a very short ground, which is like the opposite of what you're supposed to do. You're supposed to have the ground, first of all, not to a transformer mounting bolt, but hard soldered to the chassis. Unfortunately, your stamp is right here where the typical place to solder the new ground is, but we could do it right tight up against this corner. So basically this green wire is your safety ground from the wall, and instead of like Mickey Mousing it onto a transformer bolt, we get the big iron out, heat up the chassis, and connect it forever there, kind of like these ones have been done at the factory. So we'll do that here. And also this green wire, the safety ground, should be the longest of the wires in the power section, because if one of these were to come out, like if this cable gets yanked, the first thing that's going to get torn out is your safety ground, which means chassis could be live, people could get zapped. So I would say, and yeah, this strain relief is not a real strain relief, it's just got a zap strap on it on the inside, which, you know, will help if it gets a big tug, but if it gets a real big tug, that zap strap's coming off and the safety ground's coming out, and if this stuff's still alive while that safety ground's not on, then bad things can happen. So I would say, it's a fairly long cable, so I would say let's push some more in, splice it, make the green wire the longest wire, solder it directly to the chassis, and then do the neutral and the hot. And they've done that backwards too. So the neutral is going to the hot on the courtesy outlet at the back, and the hot is going to the neutral. So that's not great at all. So that needs to be reversed as well. Let's see where they took it from there. Still going through the ground switch, which makes no sense because this is should be out of the circuit now that the depth cap's removed. So you should essentially take from the wall to the courtesy outlet to the fuse to the switch, bypassing this completely. because right now it's still possible to actually invert the polarity of the AC feeding this thing, which you don't want. Alright, few burn marks here and there on the transformer leads, some sloppy iron action. Heater windings look proper. And output transformer, yeah, they went around that way, but that's fine. Okay, so yeah, I'd say we should clean up this AC stuff just for safety. You don't want to be zapping yourself or anybody else that plugs into your amp or plugs their pedal into the back of this courtesy outlet or something, and the polarity's reversed, and you don't want that, and you don't want this ground coming off. Like, let's check this bolt that's holding on your safety ground. See if it's like doing its job, because the weight of this transformer and the vibration over time, these bolts get pretty loose, and that's what's connecting your safety ground. This cable back where it was for now. So let's see. Yeah, like a very easy turn and a half on that bolt that doesn't have the extra burden of being the transformer mount. So let's check that one. Oh, it's just like finger tight. So that right there is the whole reason why you don't put your safety ground to a transformer bolt, because they get loose and then your safety ground's gone and then bad things happen. Okay, so we'll fix that. Sort of a must do. Continue scouring here, but all these caps in the trim are original and probably good. Trim seemed to be working, although it was thumping. So we'll have to figure out if that's just needs to be de-ticked with the cap across here, or if some of the lead dress needs to be tidied up. Like, typically these should be a little higher and over top of this cap, further from the, this is the neon bulb that flashes, that actually generates the trim. So we can tidy up some of that lead dress, but I think other than, like, you know, I'm gonna show you the kind of status of how grimy it is in here, and like maybe some kind of spill there, or just a lot of corrosion in and around that ground solder to the control panel. More junk, more gunk, more corrosion. That could just be flux that could be cleaned up. But yeah, lots of shrapnel everywhere, you know? And when a piece like that ends up over here, shorting between 2 points on the board, bad things happen. So we're gonna clean that all up. Man, a lot of shrapnel. Yeah, well, there's your bias circuit, by the way. Probably couldn't see it from the other angle. So original diode, original resistor in the back, but replaced cap. Yeah, I don't know when it was done, and that's, you know, again, not great work. They just left the old, clipped the old lead, left it, and tacked onto it instead of lifting the board and making a proper connection to the eyelet. And this one's pretty shit too. So, you know, that cap's not expensive. So if we're doing a bunch of stuff, we might as well do that too. Don't want to lose bias. There's your bias pot. You remember bias pots? That was the problem with your Fiberlux, which I hope is being good to you. Yeah, so the only thing really remaining is to lift a leg of these original brown toilet paper cathode bypass caps. See, there's 2 caps in each of these, so like that's for the cathode for V1 and 2, both going to ground. So there's 2. It's a multi-section cap. There's 2 in each. So if I lift the leg of one of them, we can measure its capacitance and if there's any leakage or anything with my fancy tester. And then we'll know for sure if they need to go, but you know, usually they need to go at this point. But if they read 100% good, then you know, it's tempting to leave them. These are the pots. Let's make sure they're all original, but they look to be date code early 65. This one might be replaced, actually, the base pot. Where is it in my camera view here? Yeah. Oh, and you still have your bright cap on, by the way. Most Deluxes, people clip one leg of that, leave it hanging so that you can always put it back. But yeah, the bright cap on the Deluxe is sort of universally panned and usually taken out of circuit. So we can do that if you want, depending on what you're playing, you know. If you're always with a humbucker or something, maybe you leave it. So that is the base pot in question as to whether it's original, because it doesn't have a date code that I can see. And in fact, oh yeah, they're just not CTS, which is kind of interesting. But yeah, they're factory. 19th week of 65. I don't know if you can make out the date codes on the camera, but they're written on the side of the pot on these ones instead of on the face of it. But yeah, they say. Okay, so we got it out of the chassis, and it has seen some heat, some serious heat at some point in its life, but that's okay. It's survived-ish. Lots of non-original mounting hardware, like these washer and nut on the chassis straps is not right. It should just be Kep's nuts, or at least a lock washer. So we found 2 Kep's nuts in the bottom of the cabinet, so we can use those, and then I'll throw a couple more in there and we'll have at least good solid connection. If you want to get official Phillips pan-headed chassis bolts to make it proper fender, we can do that too, but at least with the Kep's nuts on there, it won't be getting loose and sliding out on you. Okay, so we have a replaced reverb transformer. It's a Haybor, I think. And they make good stuff. But it has been replaced. So that's, you know, a shame, but not the end of the world. The output transformer, the choke, and the power transformer all are about what we'd expect on the date codes there. So we got 10th week of 1965, 14th week of 1964 on the choke, and the 47th week of 1964 on the output transformer. So that's cool. Whoa, somebody has been in here though. I don't know. I'll tip it so you can see, but that screw holding in the output transformer here is stripped all to hell. Not sure why someone's been reefing on it that hard, and it's actually, the tab is a little bent too. So we'll investigate, straighten that out, tighten down all the hardware that is here, bias pot, and we'll check out the filter caps, probably in that order. So I can't really tighten that side of the output transformer anymore because it's stripped, but it does feel tight at least. Choke, pretty tight. It's good. Replacement reverb transformer, tight. Let's see what we got in here for tubes. First of all, I want to check that phase inverter in case my suspicion is correct. Nope, it's a 12AT7. So we're getting hot gain from somewhere else, or maybe a taper on the volume pot's just a bit off. Quick check on the hardware on the tube sockets. It's all tight. So I think we're good there. Alright, let's take a peek in the doghouse. A couple of non-original mounting screws here as well. A bit too long. And a wrong shaped head. At least they're Phillips. Here's another one. Be good to maybe put them back in those same places because the diameter's likely a bit different and might have bored out some of those holes in the chassis that it mounts through. Okay, let's see what surprises we have in store in the doghouse. Yeah, we literally have 4 different screws for the doghouse cover. 4 unique screws. Okay. I might have to watch the video, put them all back in the right spots in case the holes have been bored up. Alright, well. Oh yeah. So, it's been recapped, but by someone that is not cool for a few reasons. First reason is that they used IC caps. This company is just notoriously cheap and shitty, and these are the ones that cause lots of trouble and everybody's amps blow up and die. I don't know this manufacturer. Chemcon, Japanese. And anyway, this is also super wrong value, unless they've gone in series here. No, these are in parallel, and the value is just dumb. So you're supposed to have 2 16s in parallel, and this is a 47, and they've conveniently mounted it upside down so I can't read the other one, but I think it's a 22. Yeah, so this is 22 and this is 47 for a total capacitance of over 70, which your rectifier tube is not going to like. Are we GZ34 here, or are we 5AR4? Very loose socket here too, by the way. Yeah, we're 5AR4, which for this power transformer we should be GZ34. Oh, sorry, 5AR4 is GZ34. It's 5U4GB. That's the other one for the later transformer. So this is correct rectifier tube. But it is very loose. Like you should require a lot more force to get it out of the socket. So we'll probably end up tightening those pins. Like if you can see in there, which you probably can't, but there's 3 sort of sides to each little hole in the socket has 3 splays of metal that have sort of come apart and don't grab the pin of each tube pin properly, so we'll just get in there with a fine pointed tool and close them a bit so that each tube pin grabs solidly and isn't going to fall out. We could also put some bear traps on these to hold them in place like they have on the bigger amps, like your Vibrolux probably, if you look on the back, has the bear traps. Similarly loose on the 6L6s, a little tighter, so that's good. But still, yeah, it should be more. It should be harder than that to get the tube out. Just remember, this thing hangs upside down and vibrates a lot. Anyway, the other thing that's bad about what's going on here is that they didn't remove this board and take out the old stuff. They clipped the old caps off and soldered to the leftover leads. Maybe I'll zoom in there. Yeah, you probably can't see it like that. I'll just pop it up for 1 sec. Okay, sorry, my phone ran out of space there. But I think that's, a good place to stop. We've sort of established that we should probably do the filter caps. We should fix up your power, and I might need to get you a new strain relief, like an actual clamping strain relief. And probably do the bias cap while we're in there. We'll check the cathode bypass caps. You can sit and think about the resistors, and we'll just do general cleanup and get rid of all this flux and excess solder laying around so it doesn't short things together that don't want to be shorted. Clean the input jacks just because that's what you got to do, and just clean up in general. I guess the good news is no funny mods have been done, really. The bad news is the work that has been done was not done with great care or precision. But it's this is a genuine specimen of a really cool amp from a really cool era. So it'd be good to get it safe and, back to as close to what it was at the time as possible and make it good and reliable. So yeah, that's where we're at. Have a think. Let me know, and we can just do whatever bits of this that you want. We'll just take it from there. We can have a chat about it.